Greetings. My name is Austin. It's February 12th at about 9:45 p.m. This is my video demonstration for assignment number 3. For some reason, I started to lose my voice about 6 hours ago, and it hasn't gotten any better. So if you can't understand me, my apologies. But I'm just going to go ahead and demonstrate here. You'll see that there's problem 1A, problem 1B, and calc. I'll show you what calc is towards the end here. 1A is the factorial. We'll just do something simple, maybe 22. And we can see here that it gives not only correct output, but the desired output. How do we know that it's correct? Well, let's just pull up the calculator here. So the value is 22. 1.12 times 10 to the 21. That's, man, looks about right. Here's what's kind of cool about this program is that it actually uses double. This means we can do something like 200. Ooh, look at that. Fancy, fancy. And if we pull up this, let's do 7.886, and looks like we have 7.8865786. So looks like that's the correct value to the power of 374, which makes it, I believe, larger than a Google, which is pretty impressive given that it's just a little C program. Alright, let's do e to the x. This one was a little bit of a challenge, especially the for loop running backwards to calculate the series, and the equation that was given wasn't in its most, let's say, comprehensive form. Nonetheless, I tested this in 4. I'm going to test it in 5. Let's do something that will demonstrate how n can greatly affect this. Let's do 6. Okay, it is in series, so we have e to the power of 5, where the series n is 6. Let's go ahead and test that right here, e to the power of 5. And we can see that we don't really get anything that's like close to that, really. So we rerun it here. We see 5 and we give it like 20. And then we actually start to get values that represent it just a little bit closely. But we can see that it diminishes at about the, I'd say like rounding about the 4th decimal place right here. I don't know if you can see through this screen. I bet you can, so I'm just going to do this. Goes 413159. This one loses accuracy at about the 4th digit. So we can rerun it, and we can put n for about, let's say 80. Oh, that's not good. Hang on, I just put x as 80. Alright, I believe we were using x was 5. Let's do 80. So you can see that we get a number that's pretty comparable, only this time it's 4131 and then 62. So rounding this, it would be about 6. So now, because n is larger, it's taken more accurately to a larger decimal place. This is almost because it acts like a limit. It approaches the value of e to the power of x as n approaches infinity. But we can't really have this program run in an infinite loop. At least I don't want it to, and my memory certainly doesn't want it to. So instead we just run it and we ask the user for a value. Let's go ahead and test another one. Let's do like maybe 10. Although to be honest, I haven't tested any values this large. Alright, so we took it to be 80 again. So it should be accurate to about the 4th decimal place. Let's go ahead and check that out. Ugh, man. Ugh. I'm telling you, take emergency and get lots of sleep. You don't want to get this sick. Anyways, looks like it's about 22,026.46. That looks about right. Only this takes it to 5.7. This looks like it's about 6.7. So as you can see, it loses accuracy down here. But if we were to rerun this, we're going to do 10, 200. Yeah, we still wouldn't get super accurate values. So that really goes to show that n must be very sufficiently large as x gets large, and that's understandable. You may also notice that there's a calc program in here. Let's use Emacs. It doesn't work. I was ambitious. I've only been working on it for like less than 24 hours, but this program has the exponential in it. It has the factorial function, and then what it does is it takes arguments to the actual command line using a char argv pointer array, and then it simply tests to see what the value of them are, like times, divide, addition, subtraction, factorial, and even e in the power sign, and then it tries to run functions with it. A problem that I ran into is that it always goes to this else statement, and I haven't had enough time to troubleshoot it. But maybe one day. Until then, we just have calc, and then if we run it, it says no arguments applied. That's correct. But if we do just like 2 minus or 2 times 2, it always says invalid input. So unfortunately, I don't have that for you. But I hope that you enjoyed the rest. I hope that it was informational. You enjoy your grading process, and stay healthy.